Hi all. So let us solve the sample paper questions from this year's Cbse. We will start with section A. Let us go to the first problem. So section A, first question. A uniform electric field pointing in positive x direction. So you have a uniform electric field pointing in positive x direction. So this is the electric field in the x-axis direction. Let A be origin. So from some random point, A be origin, B be the point on x-axis at x equal to plus 1. So A is the origin. Let us assume this as A, the origin. And what is given? B is the point on the x-axis at a distance of plus 1. So A is the origin. Electric field is along x-axis. So B is a point along x-axis at a distance of plus 1. Okay. Now, and C be the point on the y-axis. C is a point on the y-axis. So let this be the y-axis. So C is a point on y-axis such that at a distance of plus 1 centimeter. So this point will be 0, 1. Okay. Now, then the potential at A, B and C satisfies. Okay. So let us consider this question. Here you can see the electric field is going in the positive x-axis direction. So, you know A and C is on the same plane. So, for uniform electric field, equipotential surface is given by parallel planes. So, C and A is in the same plane. So, potential at A will be equal to potential at C by the concept of equipotential surface from chapter 2. Now, what about potential of B? So, electric field is going. So, as it is going away from a charge, the potential decreases. So, potential at B will be less than that of potential at A. So, let us see the options. We have options, option A itself. In option A it is given potential at B is less than potential at, sorry, not option B, not option A, option B. Option B gives potential at A is greater than potential at B, or potential at B is less than potential at B, or potential at A. So option B, potential at A is greater than potential at B, because B is in the electric field direction, A is near to the charge. A and C is towards the origin of the electric field and B is away from the electric field, origin of electric field. So potential at A will be greater than potential at B. So answer for this question is option B. Okay. So coming to the second question. In the second question it is given, a conducting wire connects to charged conducting spheres such that they attain equilibrium with respect to each other. So there are two spheres, charged spheres. They are connected by a wire. Okay, such that they attain equilibrium with each other. What do you mean by equilibrium? At equilibrium, the potentials will be the same. That means after connecting, once they attain equilibrium, the potential at A will be equal to potential at B. So I can write potential at A is equal to potential at B. So potential means KQ A by RA is equal to KQB by RB. So KK cut. So you will get QA by QB is equal to RA by RB. You will get. Okay, so you will get the ratio of charges. Now what they are asking, find the ratio of the magnitude of their electric fields. So I need to find the electric field. Electric field formula is what? KQ by R square. So electric field at A is KQA by RA square. Electric field at B is KQB by RB square. So I need to take the ratio EA by EB is equal to KQA by RA square into RB square by KQB. So I have QA by QB. QA by QB into RB square by RA square. What is QA by QB? I have already have QA by QB as RA by RB. So I will substitute that. RA by RB into RB square by RA square. So what you will get? RA RB cut. You will get RB by RA. So the answer will be RB by RA. That is R2 by R1. In the options it is given as R2 by R1. So option B is the answer. That is R2 by R1 is the answer. That is option B. So coming to the third question. Third MCQ. A long straight wire of circular cross section of radius A carries a steady current I. So this cylindrical wire is carrying a steady current I. The current is uniformly distributed across its cross section. So current is uniformly distributed. So current I is flowing throughout the wire. Find the ratio of magnitude of magnetic field at a point A by 2 above the surface of the wire and at a point A by 2 below the surface of the wire. So if this is the wire, current I is flowing through it. The current I is flowing through it. You need to find the magnetic field at a point A by 2 above the surface and at a point A by 2 below the surface. So P1 is a point A by 2 below the surface and P2 is a point A by 2 above the surface. Okay, so we will consider this as a long straight current carrying wire. Magnetic field due to a long straight current carrying wire is given by B is equal to mu 0 I by 2 pi r. We will use that formula. Okay, so magnetic field at P2. Magnetic field at P2, let it be B2, is equal to mu 0, the current is I by 2 pi. What is this distance? From the center till here it is A plus A by 2. So total is A plus A by 2. So the total distance from the center is 3 by 2A. 3 by 2A. So 2 cut. So you will get mu 0 I by 3 pi A. Now we have to find the magnetic field at P1. Let us find magnetic field at P1. So B1 will be equal to. So at P1, see, this is the total wire, okay. So the total current is I. So through halfway, what will be the current? Through the halfway, the current will be I by 2 because current is uniformly distributed. So the total current is I. So halfway current will be I by 2. So this A by 2 is, this much current only is flowing through A by 2. So that means it is I by 4 is only flowing. Okay. So this is actually due to the magnetic field at P1 is actually due to I by 4. 1 by 4th of the current. Whereas for P1, the entire current is there. So magnetic field will be due to the entire current. Whereas for P1, so current will be this much current. What is that current? It is only the I by 4. 1 by 4th of the current only will be flowing. So mu 0 I by 4 by 2 pi and the distance is A by 2. So it will be mu 0 I by 4 pi A. So you have to find the ratio of B1. They are asking us to find the ratio of B2 by B1. Yeah. So finding the ratio B2 by B1. B2 by B1, you will get mu 0 I by 3 pi A into 4 pi A divided by mu 0 I so you will get it as 4 by 3. So you will get the answer as 4 by 3. That is the option C. Option C will be the answer 4 by 3. Option C will be the answer 4 by 3. So coming to the next question, question number 4. The diffraction effect can be observed in both sound waves and light waves. Okay. Diffraction is shown by both sound waves and light waves. So that was option D. Now, next coming to the question number 5. A capacitor consists of two parallel plates with area of cross section 0.001 meter square. So, area of cross section is given by 0.001 meter square, separated by a distance of 0.0001 meter. Separated by a distance of 0.0001 meter. If the voltage across the plates varies at a rate of, so rate of change of voltage, that is dV by dt is given. Given as 10 raised to 8 volt per second. Then find the value of displacement current. What is displacement current? That is from EM waves chapter 8. Displacement current is given by epsilon naught into d phi by dt. So, we know ID, the displacement current is epsilon naught into d phi by dt. Here rate of change of flux is not given, but we know the flux is what? E dot A. Flux is E dot A, area is given. And that electric field you can write it in terms of potential gradient, V by D terms you can write. Okay, so we are going to apply that. So epsilon naught into d by dt of flux, I will put it as E dot A. And area I will take outside the differential, and for E I will substitute V by D. So epsilon naught A into dV by d by dt. And here d is also, the distance between the plates of a capacitor is also a constant. So I will take that also outside. So epsilon naught A by d into dV by dt. So all the values are given. Epsilon naught constant, A, D given, dV by dt is also given. So directly when you substitute, you will get the answer. So let us substitute that. ID will be equal to epsilon naught is 8.85 into 10 raised to minus 12 into area is given as 0.001 meter square. 0.001 divided by 0.0001 into dy by dt is 10 raised to 8. 10 raised to 8. So let us simplify. This is 8.85 into 10 raised to minus 12 into 10 raised to minus 3 into 10 raised to 8 divided by 10 raised to minus 4. Minus 4 and minus 3 it will be minus 1, minus 1 and minus 2 it will be minus 11. So 8.85 into 10 raised to minus 11 and 10 raised to 8, 10 raised to minus 3 ampere, or it is 8.85 milliampere. So in the options we have 8.85 into 10 raised to minus 3 ampere. So option A is the answer for question number 5.